An extraordinary event is unfolding with impeccable timing. The rare object known as 3 Atlas is passing close to Mars. As of October 4th, 2025, it has begun to drift away from its nearest point of approach, though it remains close enough to capture the scientific community's attention. Just a day earlier, on October 3rd, it reached its minimum distance from a red planet. From Earth, however, this spectacle remains virtually invisible because the sun's intense glare completely obscures it. As a result, the only clear observations come from spacecraft orbiting or exploring Mars. Strangely, several NASA websites and live feeds have gone offline due to a government shutdown, right at the moment when real-time updates are most critical. The coincidence has raised suspicion, especially since access to public data is restricted during such an extraordinary interplanetary encounter, while researchers around the globe rush to study what could be the most unusual object ever found in our solar system. When 3I Atlas was closest to Mars at roughly 30 million kilometers, the ongoing NASA shutdown halted communications, cutting off access to already gathered data. Speculation has surged. Some experts suspect the object could be an extraordinarily active comet, unlike any previously discovered. Others take it further, suggesting it might be an interstellar probe, possibly artificial, or even a technological craft of unknown origin. Regardless of what it is, the timing of this blackout has fueled numerous questions. One significant clue emerged on October 2nd when NASA's Perseverance rover recorded a faint streak in a multi-minute exposure. The pattern doesn't align with normal sky trails caused by Mars's rotation. Instead, it cuts across those trails at a consistent angle in multiple frames, confirming that it's genuine movement rather than an imaging flaw. The streak's rapid motion suggests it may indeed be 3 Atlas. Credit belongs to Drew, who identified the anomaly and shared it online, inspiring closer analysis. The object's actual size remains uncertain, though estimates indicate it spans at least 5 kilometers and could be much larger. Intriguingly, it lacks the pronounced dust tail typical of most comets. Instead, it appears surrounded by a large, faint halo, a diffuse cloud made of ionized dust and gas. Moving at an incredible velocity of around 60 kilometers per second, it's projected to accelerate to nearly 68 kilometers per second as it nears perihelion in late October. Around September 25th, a solar coronal mass ejection struck the object, possibly energizing its outer layers. Observations collected on September 27th and October 2nd revealed no signs of fragmentation or sudden brightening, only a gradual and steady expansion of its gaseous shroud. That's why NASA's communication blackout has been such a disappointment. This was a moment people longed to witness as it happened. Fortunately, data continues to flow from other space agencies. ESA's Mars Express and the ExoMars Trace Gas Orbiter both captured images and spectral readings during the close pass, examining its motion and composition. Even the JUICE mission is expected to cross paths with the object as it approaches the Sun. However, interference from the Sun will delay radio communication between Earth and Mars, meaning much of the data will arrive later. Even so, when combined, the observations from Europe's orbiters may deliver the clearest view yet of 3I Atlas. For now, all attention has shifted toward the ESA, which remains the best source for the next breakthrough images. The European Space Agency released new results from the ExoMars camera aboard one of its orbiters, appearing to confirm the detection of the interstellar visitor, 3 Atlas. Determining the actual size of 3I Atlas is no simple task. Measuring a comet's true dimensions is challenging because its dense nucleus lies hidden within a radiant shell of gas and dust known as the coma. As it approaches the Sun, the ice in its structure vaporizes, releasing gas and particles that create the luminous halo and tail commonly associated with comets, often causing them to appear larger than they are. A Harvard-led research team involving Richard Clout, Avi Loeb, and Peter Vias addressed the dilemma by examining data gathered between May 15th and September 23rd from 227 observatories worldwide, coordinated through the Minor Planet Center. They compared the comet's actual trajectory to the path it would follow under strictly gravitational motion. Their findings indicated a tiny but measurable non-gravitational acceleration of less than 15 m per day squared. Such an effect usually results from jets of vaporized material erupting as sunlight warms the surface. Yet for 3I Atlas, the outgassing appeared far too weak relative to the energy released, implying an extremely dense nucleus resistant to those forces. From this, the scientists inferred that its core weighs over 33 billion tons and measures about 5. kilometers across, excluding its vast surrounding coma. This makes it between 3 and 5 orders of magnitude heavier than any prior interstellar objects known. Loeb observed that, based on existing models of interstellar debris and object sizes, smaller wanderers should have been detected long before encountering a body of this scale. Its discovery, therefore, marks 3I Atlas as an exceptional anomaly. He even proposed that its mass, perfect trajectory alignment, and early findings of nickel unaccompanied by iron might indicate something non-natural, perhaps technological. NASA researchers, however, continue to urge caution. The prevailing interpretation still holds that 3I Atlas is most likely a natural body, since imagery clearly reveals active gas emissions and a visible coma surrounding its nucleus, the unmistakable traits of a comet in motion. Yet not all experts focus on the object's composition. Some wonder about its purpose. Astrophysicist Suzanne Falsner has proposed a bold, elegant possibility that 3I Atlas might be a planetary seed, a fragment from another stellar system capable of triggering planet formation. But how could a wandering body ignite the birth of new worlds? Imagine a young stellar system wrapped in a swirling disk of dust and gas as its star begins to shine. Grains of matter collide, sticking together and gradually forming pebbles, then rocks, and eventually planetesimals, the precursors to planets. Over time, gravity pulls in additional material, forging full-sized worlds. The challenge lies in timing. Protoplanetary disks dissipate within a few million years, leaving little room for giants like Jupiter or Saturn to form. Falsner's hypothesis offers a clever solution. If an interstellar traveler like 3I Atlas plunges into such a nascent system, it acts as a ready-made nucleus for rapid accretion, speeding up the planet-building process. Her simulations indicate that massive stars are far more efficient at capturing such interstellar bodies than smaller ones, aligning closely with the fact that large planets are disproportionately found around larger stars. The correlation between her theoretical results and astronomical surveys is striking. If accurate, interstellar visitors such as Oumuamua, Borisov, and 3I Atlas may be more than mere drifters. They could serve as the seeds of new planetary systems. Some may have birthed gas giants in other star systems and potentially even influence the formation of our own solar neighborhood billions of years ago. Though still speculative, the theory opens an exciting frontier. Interstellar objects often appear without warning and vanish just as suddenly, but this time, detection came early. With advanced instruments tracking it as it moves, humanity may finally gain insight into what these mysterious celestial travelers truly are, while they are still within reach, not after they fade into the depths of space.